So this topic, you can probably say, is the elephant in the room. It's a thing that we know that we're going to have to address if humans are going to become a spacefaring species in the long term. But at the moment, it's still pretty much the elephant in the room, so to speak. And there are also lots of really meaty ethical questions associated with pregnancy and childbirth in space, and the idea of how the principles of evolution and natural selection might apply, and will we actually be evolving a new race or a new subspecies of humans. So today I'm going to talk briefly about space effects on human reproduction, medical care, the role of gravity, the rights of the child, and in particular early development, radiation effects, growth and development, and other challenges for child health, and then a few concluding remarks. So if we're going into deep space, we really have to think carefully about medical care, and particularly thinking that the Orion capsule, for instance, is designed to take only 4 people. You really have to work out the best possible solution for the maximum medical and healthcare provisions, at the same time as recognising that you just have a very limited crew capacity, and you're going to need people with a lot of other skills as well as healthcare skills. And of course, if you're thinking about obstetrics and paediatrics, they really require specialised knowledge. Not everyone is good at those sort of things, and you do need additional training to be a really good practitioner in those areas. So we're going to need to think about, do we take generalists or specialists or both, or generalists with additional special training? So there's a lot of discussion about those issues going on at the moment. We also need to think about communication and evacuation. So if you're on the International Space Station, evacuation is possible within 24 hours. There's minimal delay with communications on the moon, just also a very minimal delay in communications. Maybe evacuation might be possible depending on how acute the healthcare emergency is, but you are looking at least 2 to 3 days. And with Mars, there's always going to be a considerable communication delay. Depending on where the Earth and Mars are lined up, it can be anything between 8 minutes and 24 minutes each way. And once you burn those engines and set off for Mars, there's no turning back. So it's quite unrealistic to think about evacuation. Telemedicine is great, especially when you're closer to the Earth. It's great for advice, instructions, but there are limiting factors. You do need to have enough electricity to run it. The technology needs to be working. You've got to think about your communication delays. You're going to need good space weather that's not going to interfere with the technology. So the further out you get, telemedicine is going to have to be more of an adjunct for an autonomous health service. And robotic surgery will probably eventually come into its own. It's not there yet, but once again, it's a topic that's under consideration and development. So when telemedicine isn't available, astronauts are going to need to be very self-reliant. They're going to need a good knowledge base, training skills, good teamwork, and access to a large digital database of medical information. In terms of spaceflight, the current restrictions are that people under 18 years are not allowed to fly, and the youngest person who has been on a Blue Origin mission was 18 years old. Pregnancy is also an absolute no-no, so female astronauts have to undergo pregnancy testing during training and before spaceflight, because the risk is just regarded as too high, too many unknowns, and it's also a considerable concern for places like Antarctica. And as well as just the immediate issues associated with pregnancy, you've got to think about care of the pregnant woman, how you're going to be able to assist with birth complications or care of a newborn, and the crew might not actually have the skills that you need. And if a child is born prematurely or born with complications or born with a disability, you're just not going to have the specialised neonatal care that you need. And also in a very small, close-knit crew, if something bad did happen, there could potentially be devastating psychological consequences for the rest of the crew. So all these sort of heavy ethical issues play into the fact that at the moment, pregnancy is just not even being contemplated. In terms of space effects on the reproductive system, pretty much they're bad all round. And we need to think about spaceflight as well as microgravity, radiation stress, sleep disruption, and the extensive exercise the astronauts have to do each day. For female astronauts, once they're over 35, they experience the normal age-related changes in fertility. And studies have found that their effects on the menstrual cycle, likelihood of pregnancy, neonatal survival, ovarian function, estrogen production, testosterone production, and sperm production. So those are all pretty serious considerations. And space radiation in particular has very adverse effects on ovarian capacity and germ cell destruction, DNA damage. So in both genders, this could lead to genetic mutations in offspring and sterility or infertility. So what countermeasures do we have at the moment? Contraception is obviously your first line strategy, but also the use of assisted reproductive technology for both genders. And once again, that's something that's been discussed and has been put in place for astronauts. So now we're going to talk about our old friend gravity, and I love this sculpture. I think it absolutely represents what we're talking about here. And we have to think about life on Earth's evolved over the last 3.7 billion years, roughly, to live under the influence of gravity. And Homo sapiens started emerging probably about 500 million years ago, and Homo sapiens has been the dominant human species for the last 15,000 to 40,000 years. So in the whole time frame, that's relatively short. But then when you think about 60 years for human space flight, then that's just like a grain of sand or a blink of an eye in the context of 3.7 billion years. We also need to think about different gravitational environments. So we have 1G on Earth, which we love and we're very used to. On the Moon, it's just 1/6, and on Mars, 1/3. And then because of the way gravity works, it's related to the size of the object. So bigger planets like Jupiter and Saturn have higher levels of gravity compared to the Earth. And if we're going to think about reproduction in space, then we do need to think about the whole process from start to finish and sort of all the complex phases and all the steps, and tackle those one by one and look at what the potential effects are going to be. And one interesting study found that there's actually a profound influence of spaceflight on oxytocin, the feel-good bonding chemical, and this could have unwanted effects, both in terms of people wanting to get together and make babies, and there's evidence from rodent studies to show that rats, perhaps somewhat surprisingly, become a lot less interested in space than they would otherwise be. And oral contraceptives also reduce circulating oxytocin levels. And thinking about the longer term effects, if you've got reduced oxytocin, is that going to affect bonding for the mother and the baby, the interest in having future children? And so is this going to end up being a generational effect for human reproduction in space? And in space, because of the laws of physics, for a reaction, there's an equal and opposite reaction. It's not quite so straightforward to get together as it is on Earth, and maybe physical methods of keeping people together will need to be developed or experimented with. And also, if you think about normal reproductive processes, things like the direction that sperm travel in, it's always with some kind of a vector to gravity. So in the absence of gravity, are they still going to know what direction to travel in? Will chemo attractants be enough, or will the absence of gravity have an effect? And the same with the fertilized egg. Is it going to know that it needs to travel down the fallopian tubes, down into the uterus and implant, or is it just going to aimlessly hover around in the fallopian tubes? And if so, there might be a higher risk of ectopic pregnancies. Also need to think about the normal physiological changes in pregnancy, which are quite substantial. I'm not going to go through this, don't worry, but just to show you that there are a very great number of changes. And so in space, we don't know whether these are going to be adaptive or maladaptive. And because so many fewer women have flown in space than men, we already don't have a really sound understanding of female physiology in space, let alone the physiology of pregnancy in space. Also, the effect of the immune system. There's immune system dysregulation or suppression in the spaceflight environment. And what's the effect of pregnancy going to be on this? Is this going to suppress the immune system even further? So are pregnant women going to be at greater risk for contracting illness in space? And then you have to match that up with the increased virulence of some microorganisms in space. So this in itself could be another perfect storm. So I'm just going to look a little bit of the research data, mainly in rodents, as I mentioned before. Pregnancy's been shown to be feasible. And interestingly, fertilization can proceed what appears to be fairly normally, but embryonic development's often arrested or delayed. There's quite a bit of evidence of early pregnancy loss, and the data suggests that it's particularly early embryonic development rather than during the second half of gestation, which can proceed fairly normally. And that has a lot of similarities with human development, that the first trimester of pregnancy is the most dangerous in terms of things going wrong. Radiation could have a very significant effect with things like malformations, growth retardation, and central nervous system abnormalities. And astronauts would experience quite a substantial amount of radiation on the way to Mars. And this definitely falls within the range in which birth defect risk increases. And solar flares can also increase the radiation dose. And we have to think about how much and in what ways decreased gravity would affect fetal development. There's been shown an effect on human bone marrow stem cells. Fewer cells were generated. So is that going to mean abnormal development? And as I mentioned before, if you have a child with birth defects or born prematurely, they're going to be much harder to care for in an austere environment. Oops. So I'm not going to go through this, but it's just to basically tell you that there are proteins which affect the way that cells develop, and they actually form their shape, and the shape is developed in such a way to withstand gravity. And this mediated response to gravity is involved in the maintenance of bone and skeletal muscle. So in the absence of gravity, is this response actually going to occur? Are cells going to be able to develop that gravity withstanding shape? So that's another really interesting question. Some other effects which have been found is the vestibular system, that it does appear to develop abnormally in the absence of gravity. There's been evidence from rat fetuses, and so if the development of your vestibular system, which is important for balance and proprioception, if that's interrupted, does that mean that a child conceived and born in deep space is going to have trouble standing, balancing, orientating themselves once they come into a gravitational environment? We also need to think about the environment itself and the quality of the air and increased levels of carbon dioxide, both of which could be harmful to a developing fetus. Now, I'm not going to go through this, but this is a summary of a number of hypogravity and hypergravity studies with rats. And a lot of the outcomes showed that there was increased risk of spontaneous abortion, reduced gestational weight, reduced birth weight, and reduced survival for offspring. And seemed to be even worse for hypergravity than hypogravity. So you might say, well, why does that matter? And how it could matter is the transition between gravitational environments, because if you're going from microgravity, for instance, to Earth gravity, then in relative terms, you're going from hypogravity to hypergravity, the same as if you're going from the moon to Mars or going from Mars to Earth. So these sort of factors could potentially play in as well if a child was born in one environment or started developing in one environment and then had to transition to a higher gravitational environment. If we think about the business end, getting towards birth without gravity, will the baby know it needs to rotate head first prior to birth? Will you have an increased risk of breech or bottom first presentations if it doesn't rotate? And also positional birth complications where you have a leg or an arm sticking out. And where you have positional complications, you often have to intervene, and there's a much higher risk of adverse outcome for both the mother and the baby. And in terms of giving birth, there's been some really interesting studies around this with rats. Once again, it's very dynamic, lots of pushing and pulling, so those laws of physics and microgravity will come into play as well. It's also quite messy, lots of blood and fluids behave differently in microgravity. Venous blood adheres to the local surface, but arterial blood will spurt out and form droplets. So there's a lot of potential for contamination as a result of both of those. Any kind of surgery, let alone emergency cesareans, is going to be challenging in space. And you won't be able to use inhaled anesthetics like nitrous oxide, which is used very commonly during childbirth because it's a closed environment and you don't want to end up anaesthetising everybody in the spacecraft. Really interesting studies that showed that pregnant rats who'd been to space needed twice as many contractions to deliver because they had weakened abdominal muscles. And this was because the transverse abdominal muscles, which are used in contractions, are needed for postural control under gravity, but they weren't exercised during spaceflight. So they decreased in their strength. And the mammal births that they looked at on the International Space Station were found to be more difficult during labour and more likely to result in stillbirth. So there's probably implied in that human births might potentially suffer from the same difficulties. I'm just going to touch briefly on the rights of the child. So on Earth, we have this framework under the United Nations called the Convention on the Rights of the Child, which tries to give every child the best possible environment and upbringing. And we have strategic development goals to support that. And I'm sure you've all heard of the determinants of health, and those include socioeconomic, cultural, environmental determinations of health. And if you look at the wheel on the right here, there's probably going to be a lot of these things that are difficult to deliver in space or are going to be suboptimal in the space environment. So that's going to be a real challenge as well, to be able to provide children with what they need for healthy growth and development. Also need to think about the environment that we're taking children into. So Earth and Mars are vastly different in terms of their atmospheric composition, gravity, and radiation in particular. There's a whole lot more surface radiation on Mars than there is on the Earth, and minimal protection from solar radiation. Mars only has a very, very thin atmosphere, and it doesn't have the benefit of the Earth's magnetic field provides in terms of protecting us. If we look at ionizing radiation, which is cosmic radiation, and the X-rays and gamma rays from solar flares, this is a known carcinogen. Children are particularly vulnerable, particularly earlier in life when they have high rates of cell division and developing tissues. And because they live longer, the potential for accumulated damage is greater. And fetuses are particularly sensitive to ionizing radiation because of their very high rates of cell division and also differentiating into mature functional cells. Now, I'm just going to point out a couple of things on this slide. So if we look at child growth and development, we can see that we're wanting to have upward curves, and there are various growth spurts as well. But if you look at this diagram here, you'll notice this is hypothesized on a flight to Mars that you're going to have consistently declining bone strength and muscle strength. So if you were to superimpose those two pictures on top of each other, you'd see that what's hypothesized to happen on the way to Mars is not going to be good in terms of child growth and development. And particularly in the very early stages of childhood, there are so many aspects of developmental milestones that have to be achieved. And I'll talk more about that in a moment. Bone development carries through to adolescent, but if you don't have gravity to give you strong bones, you're going to end up with weaker bones, and are children going to have more brittle bones and be much more at risk of fractures than they are here on Earth. And if you look at this table of developmental milestones, and if you just pick anyone randomly and think about, do I need to work against gravity to actually achieve this milestone? You'd be surprised how many of them you would go, oh gosh, I never thought about it before, but yes, gravity does play a role in this. So in the absence of gravity, are children actually going to be able to reach these milestones, develop the muscles and the physical motions that they need? And really importantly, brain development and health is dependent on a number of really important factors that may be hard to provide in space, particularly the first 8 years. You need good nutrition, you need to avoid hazards, you need good interpersonal reactions, you need good care to avoid negative experiences and enhance positive experiences. And this care really needs to start before birth and continue through childhood. So if we look at the influences on brain development, positive influences come from good health and nutrition for both mother and baby, prenatal, postnatal care, newborn screening, protection from diseases, vaccinations, nurturing, education, good relationships and a healthy environment. But negative influences from neglect, stress, trauma, lack of healthcare, poor nutrition, impoverished environment, and lack of educational opportunities. So if you look at those two lists, there are a lot of things that we take for granted, but equally a lot of things that might be difficult to provide, or to provide well in a very austere and limited resource space environment. There's also a lot of evidence from adults to show that there are some quite profound neurological effects on the brain during long-term spaceflight. So it's probably reasonable to assume that children might not be immune from these effects as well. And so the impact of the spaceflight effects on developing brain is also unknown at the moment. We also need to think about all the various childhood illnesses and diseases. Some of them are avoidable, of course, if you never have any exposure to that particular pathogen, but others are not avoidable. So that goes back to the issue of healthcare, and are we going to be able to provide adequate healthcare to children? And if you look at this pyramid, the countries down the bottom that have the most issues with childhood disease and mortality, etc., are the lowest resource countries, and the wealthiest and highest resource countries have the fewest problems. So where is spaceflight going to fit into this pyramid of with the resource limited environment? We have immunisations. We have a huge number of immunisations we give to kids to avoid diseases, and also young adults and older people. So it's all fine if you've gone off to space and you weren't exposed to anything initially, but every time someone new arrives, there's always going to be the potential that some disease might arrive with them. Fortunately, vaccinations do seem to work just as well in space as they do on Earth, based on International Space Station evidence. Finally, just a little bit of fun has been suggested with space tourism that conception in space might be the ultimate trophy. And so there are a number of serious proposals for space station. Axiom is already underway. Orbital Reef with Blue Origin, that's looks as if it's also going to go ahead. And there have been various proposals for artificial gravity rotating wheel space stations, like the space station in 2001. And this one was originally named under Wernher von Braun, the father of modern rocketry. Then that proposal collapsed, but it's been taken up by Orbital Assembly Corporation, and now they've renamed it the Voyager Station. So as to whether these actually happen or not, who knows, but hopefully eventually they will. So in summary, there are really complex physiological and ethical issues we have to think about in relation to human reproduction in space. And we're going to need to do a lot more research before we start experimenting with humans. And from the ethical perspective, we actually do need to start talking about this as well before we start experimenting in real life. Just some artists' vision of what life on the Moon and Mars might look like. And I've just got some references and image credits. So I will stop there.